Hello pre-calculus students, I hope you're doing well. We are in the middle of section 11.3 on sum and difference identities for trigonometry, and I'm going to give you today some examples of some of the practice problems that are from this section so that you'll be able to complete the rest of them. So the first set says, tell whether each statement is true or false. So if I take this is the tangent of 225, and I can tell if I take 180 and I add 45 to it, I now have 225. So the question is this equivalent to the tangent of 180 plus 45? 225 is 180 plus 45. So if I took this and expanded it using our rules, it would say this. It would be the tangent of the first, 180, plus the tangent of the second, 45, divided by 1 minus the tangent of 180 times the tangent of 45. Is that what I have? And so you compare it. And I can see my signs are bad. That this one has a minus here, it really should be a plus. So this would be a false statement. The question is this true or is it false? This one is false. All right, next one that I want to do is number 6. And when you saw the introduction video, we didn't do much with these pi things, with the radian degrees, or with the radian angles. So we're going to look a little bit more in these practice problems at the radian problems. So this one's a cosine, cosine, sine, sine. The question says, write the expression as the sine, cosine, or tangent. I can tell cosine, cosine means it's cosine. So let's see, cosine. And this one with the plus sign, remember cosine, the sign changes. So this would be a pi over 3 minus a pi over 4. Well, I've got to figure out what that actually is. So now I've got to get common denominators with that. So if I get a common denominator between a 3 and a 4, it's a 12. Take the 3 to turn it into a 12, you multiply by 4, makes this a 4 pi. Take a 4, change it into a 12, you multiply by 3, that's going to make this a 3 pi. And so now I've got common denominators and I can actually do that subtraction. So this one's going to be 4 pi over 12 minus 3 pi over 12 gives me 1 pi over 12. And that's your answer. All right, so the next one that I want to go to is number 10. But let's talk a little bit about these ones in between. Remember on the intro video, you're going to take, like if you have a problem like number 8, you're going to pick two values, any two that you want, that are going to add up to be or subtract to be 255. So for example, you could use something like this, and there's more than one way to do this, but the first thing that comes to my mind is if I took the cosine, since it's cosine, and to get a 255, which is not on my chart, I can use numbers on the chart like 300 and subtract away 45, and that's going to be numbers that would be on my chart. That gives me 255. So you're going to break these into whatever combination you want that are numbers that are on your chart, and then expand them, fill in the values, and see what the number comes out to be. Again, we did problems like that on the intro video, and I know you saw some as well from the flip math video. But I want to go to number 10 because we did not on the intro look at anything like number 10. Same idea. I have the cosine. I want two angles that when I add or subtract them, I get 13 pi over 12. And they have to be values that would be on my chart. So this is a little bit more complicated, right? If I took it, I know I need to have denominators of 12. I need to get to a 13. So let's think of things that would add to be 13. I could choose 7 pi over 12 and 6 pi over 12. Let me just put that up above here. What if I use 7 pi plus 6 pi? Well, 7 pi over 12 is not on my chart, so I'm not going to use that. That's not a good combination, so that's not going to work. What if I used, to get to 13, what if I used 8 pi and 5 pi? Well, 5 pi over 12 is not on my chart, so that's not going to work. So what if I used, you're going to kind of play around with this just a little bit. What if I used 9 pi over 12 and I used a 4 pi over 12? Obviously I'm putting that in the right spots, right? Because that's one that works. 9 and 4 is 13. There it is. But this I can reduce. I don't see 9 pi over 12 on my actual chart, but if I reduce the fraction, it would be the cosine of 3 goes into both of these. 3 goes into 9 3 times, and into 12 4 times. 4 goes into both of these. 4 goes into 4 once. I just get the pi. And 4 goes into 12 3 times. Well, 3 pi over 4 and pi over 3 are both values that are on your chart. That's the whole goal of this. You're going to pick the combination that gives you values that will reduce to be on your chart. Start out with the common denominators and then reduce it from there. All right, so then I'm going to go back and expand this. This is the cosine with a plus sign, a sum of cosines. So cosine of 3 pi over 4, cosine of pi over 3. Because this is a plus in cosine, it's going to be opposite. Sine of 3 pi over 4, sine of pi over 3. Now I showed you this in the intro video, but you're going back to your chart here. And I want to get my 3 pi over 4. I want the cosine. It's going to be negative square root of 2 over 2. And that's what I'm going to put into my value first. This guy is a negative square root of 2 over 2. And again, back to the chart. I'm not going to keep flipping back and forth because you've seen kind of how to do this. So I'll tell you cosine of pi over 3 when you go to the chart is a 1/2. Then there's a subtraction sign. Sine of 3 pi over 4 for my chart is a square root of 2 over 2. Sine of pi over 3 on my chart is a square root of 3 over 2. Then I multiply before I add. So negative square root of 2 times 1 is a negative square root of 2. 2 times 2 is 4 in the bottom. Subtraction sign. Square root of 2 times square root of 3 is a square root of 6. 2 times 2 is 4. And then I just put it together because they have common denominators. So negative square root of 2 minus the square root of 6 all over 4 is my final best answer for that one. You can see the sunshine coming in with the shading on my paper here. All right, that's number 10. Here's the next one I want to do. Again, I want to pick another one that is a radical one. So here's number 12. Same idea. I have for number 12, I want to expand a pi over 12. Well, pi over 12 is not on my chart, but I need two things that would add or subtract to give me pi over 12. Now it's probably going to be subtraction because pi over 12 is really teeny tiny. You can't really break that apart into an addition type thing. So it's probably going to be a subtraction. That's the first thing that I notice. And I need the tangent of two values. I'm going to start out with the same denominator of twelfths. We think our guess is it's going to be a subtraction. Well, let's go simple. What if I took 3 pi over 12 and subtracted away 2 pi over 12? 3 minus 2 is 1. There you go, pi. And then I've got my twelfths. So let's take that and reduce it and see if these are going to be reduced values that are on my chart. 3 goes into 3 once. 3 goes into 12 4 times. This is the same thing as pi over 4. I'm like, woohoo, that's on my chart. 2 over 12. If I put 2 into both of those, I get pi over 6. And I do another woohoo because that's on my chart. So there it is, pi over 4 and pi over 6. So what I'm going to do is I'm going to expand the tangent rule using subtraction. So here's how the tangent rule goes. Tangent of the first, pi over 4. Same sign at first up the top. Tangent of pi over 6. Denominator 1 minus, actually it's going to be 1 plus, opposite sign on the bottom. Tangent of pi over 4. Tangent of pi over 6. Those two are multiplied. So I go to my handy dandy chart, and when I get to the chart, tangent of pi over 4 is 1, minus tangent of pi over 6 is the square root of 3 over 3. In the bottom, 1 plus, tangent of pi over 4 is 1. Tangent of pi over 6 is the square root of 3 over 3. And so when I put this together, I end up with this. I have 1 minus the square root of 3 over 3 on the top. These multiply to give you the square root of 3 over 3, so it's 1 plus the square root of 3 over 3 on the bottom. And we talked about this a little bit in the intro, and I know you saw it on the video from Flip Math, that they literally take this and rationalize it all the way down. We're not going to be that crazy. We're going to just take this thing, and when you get something complex fraction like that, we're going to take and multiply it by 3, so we can get rid of all the complex fraction part of it. 3 times 1 is 3. This square root of 3 over 3, the 3 on the bottom would cancel, so I get minus the square root of 3 on the top. This one, same thing happens. 1 times 3 is 3, plus square root of 3 over 3 times 3 is just a square root of 3. We're going to take and leave this as our answer. Even though I have a radical in the bottom, we're going to be rebels and call that an answer, and it's good. All right, 14 is the next one. Got just 2 more to go. We're going to do 14 is tangent 1. This is a tangent of x minus y. They give us 2 triangles. There's an x triangle and a y triangle. I'm going to create reference triangles out of that. I have to figure out what quadrant I'm in. This guy between 0 and 90, that's quadrant 1. This guy between 90 and 180, that's quadrant 2. And I'm going to create my x triangle and my y triangle so that I can actually answer the question. So, first quadrant for my x triangle. I'm in the first quadrant. Here I am. Here's x. Cosine is adjacent over hypotenuse. Adjacent would be here. Hypotenuse is here. If I do my Pythagorean theorem, 25 squared equals 7 squared plus some y value squared, I work my way through. It turns out my y is 24. Remember I told you on the intro that these are going to come out to be whole numbers. If you get something other than a whole number, you know you did something wrong. All right, so then we go to my y triangle. My y triangle is in quadrant 2. Quadrant 2, here's my y. Cosine is negative 4/5. So if I look over here, cosine is adjacent. This would be my 4 value. Well, you can see that that would be a negative x value, so that's negative 4. Your hypotenuse is 5. Guess what the missing side is? You probably know this without me showing you. Negative 4 squared plus some y value squared. It's a 3, 4, 5 triangle, so my y is 3. That's this guy, that's a positive 3. All right, so get the triangles first, then expand your trig function that you have. I have tangent of x minus tangent of y over 1 plus the tangent of x times the tangent of y. All right, this one gets a little messy with the fractions, so that's kind of why I chose this one. If I look at a tangent of x, I come over my x, I got my opposite over adjacent, so that's going to be 24 sevenths minus. Go to my y triangle, figure out the tangent, opposite over adjacent, negative, it's 3 over negative 4. In my denominator, I have 1 plus. You already calculated these out. You just need to look at your numerator here. Tangent of x is 24 sevenths. Tangent of y is negative 3/4 equals. Okay, so now I'm trying to figure this thing out. If I want to get common denominators in the top, now forget about the bottom for now. We're just going to kind of forget about that guy. We're just going to look at the top. 24 sevenths, and I'm going to plus it, because negative negative, with 3/4. I'm going to come down into the box for number 16 just so I can show you the work and have some room. So 7 and 4 gives me 28. So I'm going to have 28ths for these guys. We said it's going to be a plus because of a negative negative. This gets multiplied by 4. That gives me 96. 24 times 4 is 96, 28ths. This one needs to get multiplied by 7. 3 times 7 is 21. I might as well finish that out right at the top there. So I end up with 117 28ths. Well, that's my numerator. Now let's look at the denominator. I have a 1 plus. If I multiply these two together, I have 24 times negative 3. That gives me 72. By the way, it's going to be a positive times a negative, so really this is a subtraction sign here. So minus, and 24 times 3 is 72, and I have 7 times 4 is 28. Well, 1 is equivalent to 28 28ths. So if I have 28 and I subtract away 72, that gives me a negative 44 28ths. That's a hot mess, right? Still a complex fraction. So what I'm going to do is go horizontal like I've showed you before to do. So I have 117 28ths, my numerator, divided by negative 44 28ths. And so dividing by a fraction is keep, change, flip. So I've got 117 over 28 times, flip it, 28 over a negative 44, and I end up with my 28's canceling. Final answer for this is a negative 117 over 44. You can put that negative either at the top or at the bottom or just out in front, but it's a negative fraction ultimately. And that, my friends, is your answer to number 14. That was big. All right, last one I want to show you is number 17 on the last page here, practice problems. And they say, is this equation an identity? So it's kind of like the verifying thing, but you actually have to say, there's a possibility this time around that it may not be true. Where when they tell you the word verify, they're telling you, here's a true statement, show it, prove it. This one's saying, is this an equation that's an identity or not? So what you're going to do is you're going to expand the left-hand side. You can't do anything with cosine of x, it's just cosine of x. So you're going to work on the left. If I expand this using my rules, cosine of x, cosine of pi, cosine, plus sine of x, sine of pi. So I go either to my chart or I think about what the unit circle says for pi, and if I'm at pi, I'm at the coordinate negative 1, 0. X is my cosine, y is my sine, and so I can fill it in. So let's see what happens. I've got cosine of x, I can't say more about that. Cosine of pi is the x value, that's times a negative 1. Plus sine of x, I can't say much about that. Sine of pi is 0. So the question is, does it equal the cosine of x? Does it? Oh no, let's see. Cosine of x. Well, the sine times 0 cancels. So on the left-hand side, I get negative 1 times the cosine of x is negative cosine of x. And I'm looking at it on the right, it's the cosine of x, and they are not equal to one another. One's negative and one's positive. They're not the same thing. So that means that the identity doesn't apply. Is this an equation identity? We say no, not an identity. It doesn't work. All right, and you're going to do the same kind of thing for number 18, see if it works out to be an identity or not. All right, that's it. That's the practice problems from section 11.3. Shoot me an email with any questions. I missed you guys, and I hope you're all doing well. I'll talk to you soon. Bye.